GANs generate by competition. Our final architecture generates by something stranger. It learns to turn pure static into a picture, one small step at a time. This is diffusion, the technology behind DALL-E, Midjourney, and Stable Diffusion. It's how machines learn to paint from a sentence. The core idea sounds backwards. Start with a screen of pure random noise, television static, and gradually remove the noise until a coherent image emerges, like watching a photograph develop or a sculptor revealing a figure hidden in marble. The whole trick is learning how to denoise. So, how do you teach that? You learn it backwards by first destroying. Take a real image and add a little noise, then a little more, and more. Hundreds of small steps until the image is completely gone, indistinguishable from random static. This is the forward process and it's trivial, just keep adding noise. Crucially, we know exactly how much we added at each step. Now flip it. We train a network to undo one step of that noising, to take a noisy image and make it slightly less noisy. Since we created every noisy version ourselves, we have perfect training pairs. Here's the noisy image, here's the cleaner one it came from. Learn that one reverse step and you can chain it. Specifically, the network's job is to look at a noisy image and predict the noise that was added. Subtract that predicted noise and you get a cleaner image. It never has to paint a picture from scratch. It only ever answers one humble question: what here is noise? That's a far easier thing to learn, and generation falls out naturally. Start with a fresh canvas of pure random noise. The network has never seen this exact static. Ask it to predict the noise and remove a bit. Repeat, again and again, dozens of steps, each one a little cleaner, until from nothing but noise, a brand new detailed image appears, created by removal. Why did this beat GANs? Because the problem is broken into many tiny easy steps instead of one impossible leap. There's no adversarial duel to balance, no mode collapse, just a single network solving a simple well-defined task over and over. That stability lets diffusion models train reliably and reach extraordinary quality. But how do you get the image you asked for? You guide the denoising with a condition, usually a text prompt, encoded with the embeddings from episode 27. At every step, the network nudges the image not just toward less noisy, but toward less noisy and matching these words. Type a sentence and the noise resolves into exactly that. Doing this on millions of pixels would be brutally slow, so Stable Diffusion runs the whole process in a compressed latent space. The autoencoder idea from last episode, denoise a small latent code instead of the full image, then decode it back up to full resolution at the end. Far faster, and it put image generation on ordinary computers. Compared to GANs, diffusion trades speed for everything else. It's slower to generate, many steps instead of one, but it's stable to train, captures huge variety, and hits stunning fidelity. That bargain proved decisive. Diffusion overtook GANs to become the dominant approach to image generation. And it's everywhere now: DALL-E, Midjourney, Stable Diffusion. The image generators that put AI art in everyone's hands all run on diffusion. And the same denoising idea is spreading to video, to audio, to 3D, to molecule design. Generating by removing noise turned out to be a remarkably general recipe. And that completes the deep architectures: the MLP, the foundation, the CNN for images, the RNN and LSTM for sequences, attention and the transformer, the engine of modern AI, embeddings, the doorway in, and the generative trio, autoencoders, GANs, and diffusion, that taught machines to create. The whole modern toolkit. So that's diffusion. Learn to remove noise one step at a time, then start from pure static and denoise your way to a brand new image, steered by a prompt. It's how AI learned to paint, and with it, the architectures are complete. Next block, we leave pure design behind and go applied. Fine tuning, retrieval, alignment, and the agents built on top. See you there.